Hello, thank you, thank you. So I'm Michal, I'm GraphQLholic. I work here in Pipedrive in the Silicon Valley called Karlin. And I picked a topic for this talk to be very practical, focus on one very important part, which when we talk about GraphQL is actually how to fetch the data, how to load the data, so we can return them in a response to the client. So I think it's very important to understand what's actually going on when the query arrives to the GraphQL backend. So the GraphQL runtime starts resolving. So what it does, it takes the root of the query and it calls the resolver function. And when the resolver function of the root field returns something else than null, it passed the response from the resolver function to the children. So then it starts returning, resolving these fields, and when there is no more fields left, the query is resolved and the data goes to the client. So we get some nice JSON which we requested. So the mentioned resolver function is something like this. It's a function that receives 4 arguments and some logic has to happen there. So to be more specific, let's start with the users. When we use architecture like this, we got microservices, we got the GraphQL as a gateway, pretty common pattern. What's gonna happen in the user's resolver? We're gonna fetch some REST API there. And it could be simple like that. So the API returns, let's say, array of users and some teams and some information about the team. We take the response and pass it to the children. So the username resolver, for example, gets all the data from the parent, which is the name of the user and the information of the team. And because we are just returning the name field there, that's done. We had the data from the parent, and actually in the GraphQL, at least the GraphQL runtime, the resolver like this doesn't have to be specified. The runtime would use so-called default resolver, and it would work like that. If you return an object from the parent and the field exists in the return object, the GraphQL takes care of it. So the team was also there, so the data passed to the title and members are being resolved. But what about the members? There is a little bit different. The data that arrived from the parent only have an ID of the team and the title. Where can we get it members? So we have to call another API to get the data, and we just use the team ID to compose the request. So the response looks like this. We get the name of the member and its ID. That sounds nice. We get it as an array. So those API calls that happen during resolving of this query are these 4. We already see there is not that efficient as it could be because we fetch the members of team 3 2 times. That definitely could be improved, but not great, not terrible. It could get worse if we request more data. So in a team, we would be, let's say, interested in something like when the team was created, and in the members of the team, we would like to also have an email. Data that are not present in the API responses we already saw. So that would lead us to multiple API calls to those previous 4. We would also have to call multiple times the team detail and much more multiple times the user detail. Because when we want to return the user email, we receive the data from the parent, just the ID and the name, and we have to call a user detail to get the email and return it. So we get a bunch of API calls that still, they happen on a backend from the GraphQL gateway to your microservice, but still it's kind of a storm of internal requests. Can it be improved? Sure. sip a beer and come up with some idea. The idea could be, let's use a loader, so-called a data loader. So here in this resolver function of the user email field, we not only use the data, we also use the context argument. And the context argument is something that's being created ideally when the request arrived. I'll talk about the best practices for data loaders later. But let's say we have on a context something called user loader that provides us a method load that just needs a user ID. And what it does, it returns a promise with user data. So we just await the response and we return the email. Just with such a simple thing, we get a nice optimization. So we don't call the user detail API every time it's needed. We just call it maximum once, and all other calls are being cached and reused. It's a nice optimization. And so when I was talking about the data loader, this is actually like a minimal example what a data loader looks like. You import the data loader from a library, you extend it, and you provide in a constructor a function that only wants to receive array of IDs and call some batch function with these IDs. How does such a batch function looks like? It could be something like this. Basically, the batch function has to provide, or like, there are two requirements for a batch function. It has to return the same amount of responses as many IDs it received, and it has to be in the same order. So, like promise all settled with fetch API call in an array. That's basically it, what is needed. But you have to think about the batch function as something that you are very free to do whatever you want. So if you have an architecture like different, you don't use these microservices and internal REST API calls. It could be a database, it could be Redis, it could be whatever data source you use. Just implement the logic here and fulfill the requirements. So return a promise, the same length, the same amount of IDs you received has to be in the response and in the same order. So if I was mentioning it's up to you to do whatever logic you want, imagine you have a REST API or internal API that gives you a detail for a user and it accepts multiple IDs. You don't have to call your internal user API in a map. You can just join these IDs, call it once, and if your API returns the data, you can just return if you fulfill the requirements of the batch function, and that would be it. So you would get just a single request, which is something like, wow, because previously we had multiple and like repeated requests, and now we squeezed all these calls into a single one because our backend supports just like batch detail, provides a batch detail API. So such a like the data loader constructor can also get some options. And first option I want to mention here is this max batch size, because it can happen that you construct a really long URL, especially if you are using some UIDs, not only integers. That URL can get really long. It could lead to some errors. So imagine you can just provide this option. So data loader automatically split all your API calls to some certain size, do these chunks for you, and the batch function still works the same. So that way, it's a nice separation of concerns. You don't need to put extra logic in your batch function. It still does the same thing. It receives a couple of IDs, resolve them, And that's it. Everything else is taken care of by the data loader. And this is really like something I really like about the data loader. It scales very well no matter how complex your schema is and no matter how shitty your internal APIs are. You always can get something out of it if you start using a data loader, and you can optimize later based on some of your measurements. For example, yeah, we are requesting a lot of these APIs by a single ID. Maybe it would be great to improve the endpoint, accept multiple IDs, and wow, you just decrease the amount of internal API calls a lot. And this is even simpler if your resolvers can talk directly to database, because database usually has something like in, or you can definitely provide multiple IDs very easily. So I also want to mention a couple of more data loader options that can be handy. By the way, the data loader has pretty simple API and not that many options. So just those I find really useful are still more like 50%. So I already mentioned the max batch size to chunk the array of IDs. And there is also a batch schedule function you can provide. So the data loader by default works something like it waits just like the internal tick in the node event loop to gather the requirements, because in your resolver you always call a single load, or usually you just call load and one single ID. But the data loader gathers these requests and batch them together. So it's happening in the event loop in a tick, but you can specify your own batch scheduler. For example, for some various reasons, you want to wait, I don't know, 10 milliseconds or something you need. So you don't need to add any extra complexity. You just specify a simple function and data loader takes care of it. Yeah, by the way, I also forgot to mention that the data loader as a relay, as a GraphQL data loader also comes from a Facebook, and it's really like let's say like old pattern, because it was invented in, or it was published in 2010, and originally it was not connected with the GraphQL at all. The first implementation was in PHP derivative called Hack they used in Facebook. So that's something they used even before GraphQL, and they just ported this pattern to JavaScript and make it open source. Cache key function is another option, pretty handy, because sometimes your key isn't just a scalar, just the ID. It could be object, pretty common if you use MongoDB, where the ID is an object. So cache key function is a simple function that takes this object and provides some scalar you can use in your internal cache. And there is as well a cache map, because by default, the data loader use the standard JavaScript map. But if you need something more complex, you can just provide an object with the same API that the map has, which is like set, get, has, delete, and it could provide much more complex functionality if you need that. So these all options can be passed to the data loader. Your batch function stays the same, and data loader takes care of it. Yeah, data loader API, I already mentioned the constructor, and then there is the load function. This is what you probably will use most of the time. There are a couple of syntactic sugar, like load many, which is basically just a helper for the load, which you otherwise wrap with some promise all. And there is also clear, because when you call mutation, probably it's a good idea to clear if the entity that you mutated was already cached, so you can also clear the cache. And very interesting one is the prime. There it can happen that you will use the data loader in some resolver where you receive all the data for some entity. So the prime lets you cache those data. So any other load call would use those data. This is very handy if you can have API that provides a list of, let's say, like complete objects, because it would be a waste of resources if you just iterate the list, and when some other resolver wants to fetch the entity by its ID, you have to call the internal API, because you already had the data. So when you were processing the list, you ideally could call the prime, cache the data. So when some resolver wants the data, they would be immediately available through the internal cache. So that way, if you imagine how much things such a simple tool like a data loader provides, as I said, no matter how complex your API is, you can focus on internal API storm or whatever. Yeah, so I just wanted to mention that if you like GraphQL, and now you know that GraphQL likes Dataloader, I hope you will like Dataloader as well. And that's it. Go to GitHub, GraphQL/Dataloader, read more about it. The API is really simple, and there is multiple implementation, not only in JavaScript. So thank you, and use the Dataloader, please. Yeah, I was asked a message to Ivan. Ivan, please contact Productboard. You had wonderful questions. Or on Twitter at least, please. And Ivan has also a question. Ivan is asking how to use data loaders for nested fields, which also need data loader. Ideally, simplify your API so you don't have nested fields in the API response and just provide the ID. So if you mean nested fields in a GraphQL, I hope I explain it in the example. You just wait for the field to be resolved. There you just load use the data loader and load the field. And hopefully it already will be provided, or if it's not already cached, the request will be optimized. I hope I replied in a meaningful way. So how to use data loaders for nested fields? Just use them. Ivan, if if it was not good enough response, please contact me. Just classic pattern, not alt. Yeah, that's a better naming for sure. Yeah, it's a very classic pattern. What are the advantages of having a proxy GraphQL server calling our internal APIs in opposite of rewriting all the services with GraphQL endpoints? Good question. The advantage is you don't need to put logic in your GraphQL layer. You can keep the logic where it should be, which is the microservice itself. There ideally should be also like permissions check, visibility checks, everything. So the GraphQL layer can be very simple, fast, hopefully, and easy to maintain. Because when you rewrite the logic from microservices to GraphQL, and you also start using federation, that's a challenge. Is there any reason not to use long-lived data loaders instead of new loader per request? The reason is permissions and visibilities. Imagine your data loader lives across multiple requests, and first request cached some data, second request by some other user arrives. The data would be provided through the internal cache, but maybe the second user is not authorized to see these data. So it's much more safer, and it's as well much more simpler to create data loaders per request. But if you don't need to deal with that, it totally makes sense to have a lift data loaders or even inject some, let's say, Redis check before you call your internal API. That should be in the resolver. What are the advantages of, now I'm lost. I think I answered that. Can the custom map have async API to use, e.g. Redis to get invalidation with clear over? Yeah. Maybe create a pull request or issue on a GitHub, because I was thinking the same when I was speaking about the cache map. It probably would be a good idea to provide a Redis instance or some like wrapped Redis, but it doesn't have anything like that, and the API follows the API of a map. So you could not even use like mget for a Redis. So yeah, good question. Can batching become a performance problem if, for instance, the consumed API caches well on HTTP, given it will cache differently for different orders of IDs? Maybe. I would say measure it, and if the batching doesn't make sense, don't use it. It could be configured. You can turn the caching off. It's one of the options. But usually I see it's much more better to batch the request, ideally into a single one. The issue could be a huge response that could be solved with the chunking. So depends. I recommend measure it and decide based on the data. Is there a tool on Node.js to automatically fetch just fields that client requests in query? Most of Node.js app just load all from DB, I guess. I don't know. We have something like custom made. You can specify fields. Currently, the GraphQL is not using it in favor of simplicity. And it's, again, a questionable whether it makes sense on your internal network in these internal APIs to do optimization like that. Could happen if your storage has some like big blob, which you would always transfer. In that case, yeah. Or maybe it's just simpler to provide a dedicated endpoint that's like serving a limited amount of fields. So I'm not aware of that tool. And that was the last question. So thank you again. Goodbye.